So there are two big problems with establishing agroforestry systems. So here we are in one of our agroforestry strips. We have right now around 15 hectares where we do agroforestry on the farm, and maybe one of you has some ideas why we do agroforestry. What do you think? What are reasons for agroforestry? More diversity, yeah.
It's more weather resistant, more climate resistant.
Yeah, I think that are like the two main reasons why we do agroforestry. So like for me, one of the biggest challenges which we have right now in agriculture is we are losing at a tremendous speed our diversity. And even if we do organic farming, usually we have just one crop on the field, and then in the next year we have a different crop there, so there's not much diversity. So we try to create agro-ecosystems which are resilient by themselves, which as Ernst Götsch said, which also attract natural enemies of pests, and which also can generate more of the nutrients from the soil and give them to the field crops. So that's a big reason why we do agroforestry. And then the other factor is we want to have a system which is resilient against such droughts as we have right now. And also, in the best case, a system which is also sequestering some additional carbon. I don't think we can save the planet by carbon farming, but I think we can do a little bit of a support for our climate if we do carbon farming. So with every % of humus which we build by our agro-ecosystem approach, what do you think, how much more CO2 can we store in the soil? It's around 50 tons per hectare. So 1% humus is around 50 ton, which is quite a good amount. And what do you think, with 1% more humus, how much more water can you store per hectare? It's 170,000 liters. So you can imagine a tank for 170,000 liters, which is quite huge for every hectare if you manage to build 1% humus there. And right now, I think with the approaches we are doing, we can build around 0.1 to 0.2 in the best case of humus per year, which is quite a good amount. But we try to do everything. So we do agroforestry, we do underseeding our cultures, we do diverse mixed crops in the autumn. We do minimum soil tillage. We do it with a rotor tiller, very shallow, and we also, while we work the soil, we also spray ferment lactobacillic bacteria and on it, and then we also vitalize our cultures with compost tea and other sprays which feed the leaves. But all these things which we do are still in a development phase, so we also have to do a lot of development here on the farm, and not everything works well. And here also we have quite a problem this year with a lot of amphor and distel on the field, yeah, which is not perfect. One of the reasons I think why we do have this is we got quite a few of this distel and amphor from our previous farmer which worked here before, so he didn't manage them well, so we already got fields which were full of them. And but I also think like all these weeds, they are here for a purpose. So for example, the Rumex species here, which is growing here, is there if you have a lot of nitrate in the soil, and also if you have compactions. And it's actually the same with the, I don't know, distal, with the thistle. Yeah. So these are two indicators that you have too much nitrate form of ammonium in the soil, and not ammonium in the soil, and that you have compactions. So we are not just working the soil shallow, we also work it deeper with a decompactor, and we also spray biology into it so that the channels which we open then are fastly colonized by living soil organisms. Because if we decompact the soil and then we do nothing after it, it just will recompact again. So it just becomes stable if you work with biology, and that's why you have to have diverse intercrops and subseed all your cultures. We have different approaches to it to reduce the nitrate. I think very important is that you have always diverse crops growing on your field, and right now the agroforestry can't do much because it's still small, but I mean these are growing quite fast, these trees, so they also colonize the area under the field, and they will also take the leached nitrate, because nitrate is quite leachable. They will take it out, and then we use this like we use normally a sub-seeding mix with a lot of different cultures, with grasses in it, with different clover species, and then there's also line dotter. I don't know the English name. It's a crucifer. Yeah.
Maybe you know the scientific name.
So we have different families growing always together. So that's how we try to build the soil ecosystem. And if we have a good soil ecosystem, we shouldn't have much nitrate anymore. Because the problem with nitrate also, if plants absorb nitrogen in the form of nitrate, you know the form of nitrate, NO3 minus. They need more water to process it. So I think they need even 5 times more water than if they absorb ammonium. So it's actually quite a factor for drought resistance. And that's not the only problem. The second problem is the plants, they can't decide if they need nitrogen or not. Because if you have nitrate in the water in the soil, they just absorb it with the water. And ammonium, which is NH4 plus, they can decide if they want to have it or not. So that's why it's important to have not too much nitrate. There's always some, but if you build a soil ecosystem which is more fungal dominant, you should have less. Maybe I start to describing you a little bit what we are doing here with the agroforestry. So the agroforestry here on the farm is how do you say, inspired by Ernst Götsch. Somebody know about Ernst Götsch? That's a farmer who's originally from Switzerland and who moved to Brazil, I think 30 years ago already. And there he did a lot of research on agroforestry on his farm, and he developed an agroforestry system which he calls syntropy system. So he says there's entropy, where you lose energy in our cosmos, and there's syntropy, which is actually life energy, where you build more complex forms of life. And that's also something which we want to do here. We want to create more complex systems, because if you raise the complexity, also there will be there are new emergent abilities of a system. That's the same with our human being. I mean, actually we are just many cells and bacteria which are floating around, but organized in a complex way, and that's why there are new emergent abilities, like our brain, which works quite well and which is quite fascinating. And that's the same which we kind of try with this agro ecosystem, to integrate different trees with different purposes, and then there will be new synergies, I think. So one thing is this row of fast growing trees, where we mix different tree species because they all have different abilities to support different soil ecosystems, soil organisms. So for example, here we have so now I don't know, huh? A willow, yeah. Now we have here a willow, Salix. We have different willow species here, and most of them are hybridized. So you know, this hybridization effect, which grows much faster if you combine two genetically very different species together. And the willow, for example, fixes nitrogen on the bark, which is which wasn't known for a long time. They just discovered it a few years back. So they are free-living nitrogen bacteria called endophytic symbionts, I think. They live here underneath the bark and they fix nitrogen. And also the willow is a quite fast-growing tree, which is creating quite a good crumb structure. And then we have other, like, long-known nitrogen-fixing trees. Who knows what this is? Robinia, yeah, a robinia, which is a legume, which we know from agriculture, but in a tree form, and which also fixes nitrogen with rhizobias in the ground. We planted just a special plant of robinia, which is called Robinia pseudoacacia rectissima, or Schiffsmast robinia in Germany, which is developed in Hungary, and they make a more, how do you say, a more straight stem, yeah. And they also make less root shots. Right. So and I'm not really afraid of the robinia being invasive here in this system, because I think they are mostly invasive if you have big trees and then you suddenly cut them, and then you have a dryland grass next to it, which you don't manage intensively, and then they start to invading it. And that's why the nature protection people don't like it, because they like this grasslands which are not very fertile, where you have different species, and that's what we're not having here on the cereal field. And here we have a much more fertile soil, and we also, along the agroforestry lines outside, we work with this decompactor. It's like a not turning, a deep decompacting tool, and this is cutting also the roots, and that's why we don't have robinia roots under, like, immediately under the surface. They all grow deeper and take also nitrogen from the subsoil.
How much deep?
How deep we drive? Around 40 centimeters 40. along the line. I mean, but it depends on how many stones are there, yeah, and stuff. Yeah.
Could you repeat the variety of the robinia?
Robinia pseudoacacia rectissima. Rectissima is the variety. Yeah. Yeah, this is not really straight. I mean, they are not always growing straight, but yeah, they grow straighter. Yeah. We have some which are really nice and straight. I mean, this, for example, is quite nice. With this row, we want to have it as close as possible, because we don't let these trees become really tall. We want to prune them as pollard trees. So, you know, a pollard which is always cut at the same height and which develops kind of a head. So we want to drive with a special technique from the wine producers, which cuts here on top and on the sides. So we have like a pollard hedge. And why do we do this? Because we want to have a lot of turnover of biomass, because we want to use this row especially for the purpose of making the system more fertile. I told you, like, also the papulus, they also have the same ability as the willow. They also fix nitrogen under the bark. So we have a lot of trees here which mobilize different nutrients. They also grow deeper and can lose different nutrients which are stored in the soil because they have a much more strong root system. Like, we also know that, like, actually all the plants, they give exudates. Like, if they make photosynthesis, they produce sugars and more complex carbohydrates, and then some of it they release through the root hairs to feed the soil organisms around it. So that's why we have, we call it the rhizome, the rhizosphere, where we have a lot of microorganisms growing around the roots, because they feed on all the sugars which they get from there. And then later, if they are like, they are supported by the plant to grow, and then they can produce enzymes to lower sometimes the pH, or to lose certain nutrients from the soil, which then when they die again, the plant can absorb. So that's why every plant actually is giving exudates, and perennial plants normally they give more exudates than annual plants, because they are at the same place for a longer time. So for them, they rather invest more into the soil because they're there for a long time. You can pollard nearly every tree if you start early enough. If you cut a really outgrown Robinia at the site, it might die. But if you start from early on, you can merely do it with every tree. So we have also here, that's maple in English, I think, or? Yeah. And then what else do we have? There we have Eberesche, Sorbus aucuparia, I don't know.
Rowan tree.
And then we have another really invasive tree here, which we propagated by seed. It's Eschen-Ahorn. I have no idea. It's also a maple variety which grows like ash, but yeah. I don't even know the...
Welcher war das?
Eschen-Ahorn, der kleine da, der ist ausgesät dort. Okay. And then we have also another nitrogen fixing tree which is growing here. Yeah, which is not a legume but also fixing nitrogen. It's elder in English, I think. Elder, yeah. So it lives, I think, how are these scientific? Is a scientific name. It also has kind of this root colonizing nodules, but they are called differently than with the legumes. Azotobacter, I think. Yeah. So it's actually more effective than the leguminous tree Robinia. It can fix up to 350 kilos of nitrogen per hectare, but that's with a stand of just alder. But it's quite a good amount. So there are two big problems with establishing agroforestry systems. One are deers. So for the deers we do some protection with this for the timber trees, because if they're once cutted here they don't grow straight again. Then in the field which we might visit in the neighboring village, we did a huge fence like up there also. And then the other problem are mice. And what we do now against the mice is two things. Once we put up this sticks where the how do you say, Greifvögel?
Birds of prey.
Birds of prey. Yeah. Where they can sit and watch for the mice. So they take some of it, but not all. It's also important to have them, because if you don't put the sticks up there, the preying birds will sit up here on the top and they will break it also. So, and then we put this, which is called Göttinger Fangwanne, which we reconstructed by ourselves. So they are like small pipes and a nail, and the mouse goes in and can't go out from the other side. And then the predator birds take it from on top. So the mice are not long in there, and it works quite well.